Hey guys, welcome to lesson 6. Just fix that it says lesson 5 up there. It is actually lesson 6. So our topic today is sample proportion and margin of error. Let's get started with the warm-up. The New York Times and CBS News conducted a national poll of 1,048 randomly selected high school students. Of these 1,048 students, 692 had a television in their room. What proportion of students had a television in their room? How do I find the proportion? It's basically the number of students that have a television, which is 692, over your sample size, which is 1048. You can put that in the calculator and you end up with a number which is 0.66030. In this lesson, you'll see it's not asking you to round to a certain number. So I would do 3 decimal places regardless, 0.660. So what is sample proportion? We found standard deviation in this sample standard deviation in the last lesson. It was population standard deviation over your samples, square root of sample size, right? And today we are going to do sample proportion. So we are going to learn about a new formula here. What is that? So let's talk about this. When using sample statistics to make estimates of the values of population parameters, some statistics are much better at targeting these values and consequently yield better results. Statistics that are better at targeting population parameters that will focus on our mean and proportion. So we just found a proportion, right? Proportion is usually written as a fraction or a decimal, right? So the distribution of sample proportion. So sample proportion is written as p hat. Literally p hat. That's how you read it. P hat. From a population proportion, which is just p, normal p. And a sample size of n will have proportion is p, sample size is n, and standard deviation is this formula. Again, so you have 2 formulas based on, eventually you'll see which one to pick. Depending on what you're given, you will decide which one to pick. Today we are going to be working with our sample proportion. So let's go. So it says, what is the standard deviation of the nationwide poll concerning high school students having television in their room? So standard deviation, I told you this is the formula. It is square root of, again, write your formula every time when you're working on a question. That'll just help you remember it and understand it better. So P is your population proportion, which was what? We found it in the do now, 6.660, 1 minus 0.660 over my sample size, which is what? 1048, and square root of that. So that would be actually 0.014632. I said round it to 3 decimal places, 15. Oh, I don't know what happened. 15. Okay. So now remember, 95% of our data lie within 2 standard deviation of the mean. Therefore, our margin of error of sample means is 2 times our standard deviation. Again, this is a standard deviation for, right? This is your standard deviation for your sample proportion. That's what it is. So today, for example 1, I actually broke it down into subparts. Eventually, they won't break it down, and you'll have to figure out that you have to go it in a certain order. And you have done similar questions, so with sample mean, but today we're going to do sample proportion. So suppose the percent of seniors in high school that own a cell phone is 82%. 82% can be written as 0.82, right? And that would be my P. If a random sample of 50 high school seniors was taken, determine the following. So my N is what? 50. I want to find the standard deviation of sample proportion, right? So standard deviation is square root of P parentheses 1 minus P over N. So my P is 0.82, 1 minus 0.82 over 50, and square root of that. If you take the square root of it, it is 0.054. Okay, so that's my standard deviation. So now if I want to find, part B says find the 95% confidence level, determine the margin at a 95% confidence level. So at 95% we know it is 2 standard deviations. 2 standard deviations, so which would be what? 2 times 0.054, which is 0.108. right? And now I want to find those confidence intervals. So as we did in our past lessons, how do you find the interval? You do your mean plus your margin of error. What's the mean here? It's 0.82, right? That's the proportion. So 0.82 plus and minus your margin of error, which is 0.108. Now subtract 0.82 minus 108, you get 7.712 and 2.928, and if you add these you get that. So your intervals are in this. So remember, these are decimals. If I was to convert them as percentage, it's between the 71% to approximately 93%, right? So now, would it be unusual for 92% of a group of high school seniors to own a cell phone? So 92% is same thing as 0.92. So if whatever they're asking you, it says use statistical evidence. Anytime they say talk about statistical evidence, we're looking that does that number lie in a 95% interval. So does 0.92 lie in this interval? Yes, it does, right? So again, would it be unusual? No, it won't be unusual. So no, it is not unusual because 92% lies in the interval. If I had said 70% or 95%, like, of the seniors should own a cell phone, then I would have said it would be unusual, right? Okay, so let's do example 2. Again, I said example 1, I had broken it down into subparts, so you kind of understood what the question's saying. Here, I'm just gonna, it's not broken down into subparts. You'll have to conclude what is the question asking. A study found that all fortune cookies produced 5%. All the fortune cookies produce 5% of the fortunes are blank. The quality manager of a fortune cookie company believes that a large then acceptable proportion of paper fortunes being used are blank. Suppose she takes a sample, which is our n, fortune cookies from the production line, and 15 of the paper fortunes are blank. So our proportion would be what? 15 out of 320, right? Isn't that how we did in the warm-up also? So that would give me what? It does give me a decimal 0.046875, but when I'm working with this question, this is a rounded number. I like to keep my fraction. So I want to find my 95% confidence interval. So I basically want to find the interval, right? For that, I first need to know my standard deviation, my margin of error, and that will help me find my confidence interval. So I can find my margin of error by doing 2 times my standard deviation, which is what? Square root of p parentheses 1 minus p over n, right? That's what your margin of error is. So that would be what? I'll just zoom in. 2 times, I found my p to be, I'm going to use as 15 over 320 parentheses 1 minus 15 over 320 square root all over, the n is also under the square roots, guys, so over n, which was what? 320, right? So put that in the calculator and you get an answer of 0.024. Yes, now I want to find my intervals. So what you do is you take your proportion, right, which was this number. You can actually use 15 over 320, or you can use the decimal 0.046875 plus and minus 0.024. And my intervals are from 0.023 to 0.071, right? You're subtracting and adding these two numbers. So I'm just going to box it so that, because it got all crowded in here. So, okay. So these are my intervals. So is the quality control manager correct in stating that the larger than acceptable proportion of paper fortune used are blank? Use statistical evidence. Again, when it says statistical evidence, you should know that is it lying in the 95% range. So how much did we say? 5%, which is 0.05. Does 0.05 lie in your interval? It does lie in the interval, right? So so what is it? The quality control manager is wrong. So no. The quality, just writing no or yes is not enough, please. No, the quality control manager is not correct. because 5% lies within the interval. Right? So that's basically it. Very similar to the last lesson. So finish up your remaining of the lesson, guys. If you have any questions, please feel free to reach out.